for 11.3 B10, which is a little bit complicated. Let's do it a little slowly. Basically, you have a choice. You can either pay $150 at the end of each month for 18 months. So notice this is an annuity, an ordinary annuity. Simple because it's at the end of each month and it's compounded monthly. That's one thing. Or you can not pay anything for a year and then pay $180 at the end of each month for 18 months. So here's the timeline, t equals 0. So if you were doing the first option, you would start here, t equals 0, and then you would go along for a year and a half. That would be the end of it. If you were doing the second option, you would start t equals 1 and then move along for another 18 months. So what we are going to do is to bring both of the payments back to t equals 0 and then compare them. So here we go. First of all, we'll start with the easy one. You pay $150 a month and the I is 0.0113. N is 18 because it's monthly payments for a year and a half. Use the present value formula for all your payments. PV is 150, which is the payments. The present value formula works out at 2430.76. So at t equals 0, the value of all those payments that you make is going to be 2430.6. Now we'll move on to the second case, a little bit more complicated. So this one, you don't make any payments for a year, and then the payment is larger though, it's 180. So what we're going to do is to work out the present value of all your payments, and then we'll bring that back to t equals 0. Remember that you're starting 1 year after the other guy, so we're going to need to do this in 2 steps. So the first step is just to calculate the present value of all your payments. So that's $180. The present value formula is exactly the same as the other one, n equals 18, and this gives us 2916.61. So at t equals 1, at 1 year, the present value of all your payments was 2916.91. Remember, you didn't start doing anything for a year. Now we need to bring this back to t equals 0. So we use as our future value the present value at 1 year. So now we use the present value formula. Now notice that now we can just use the ordinary present value formula. This does not require the use of the annuities formula because there are no payments being made. All we're doing is bringing that payment back to t equals 0. There are one of few changes. You see, first of all, the formula is very simple. It's just the compound present value formula, not the annuity formula. N is 12 to the minus 12 because we don't do it for longer than a year. It's just 1 year compounded monthly. So it's the amount at t equals 1, 2916.91, and so that is at t equals 0, that's discounted to t equals 0, and it's 2546.96. So to compare them, the one where you wait for a year costs you 2546.96. The one where you start the payments immediately costs you 2430.76. So starting the payments now at 150 is better for you, it's cheaper in the long run than paying 180 and not starting for a year? It's a good question to think through very carefully. Thank you.